Hello students, welcome to the lecture on technology in Petro retailing agenda, and after this lecture we will be able to learn the following objectives. Discuss the role of technology in Petro retailing agenda, define the technology, describe the technologies and business, discuss the components of the downstream supply chain, define the distribution segment, discuss the software tools available in downstream supply chain, define the tools solve all the problems. Let's start with the concept of technology in Petro retailing agenda. The business landscape of the energy sector, especially petroleum, is becoming increasingly uncertain and unpredictable. What makes this sector much more challenging is that many of the factors that directly affect profitable operations are beyond the direct control of the organizations. Protecting the consumer against unscrupulous retailers has always been a challenge. The role of technology in petroleum retailing needs to be explored in a way that encompasses the interests of multiple stakeholders, namely supplier, retailer, and consumer. Let us now discuss the role of technology in Petro retailing agenda. The gas station is the final point of sale in the petroleum supply chain. This is the touch point with the end consumer and hence becomes the most important functional point in the entire supply chain. Petrol retailing markets are evolving rapidly worldwide. These markets are also becoming commercially competitive as price controls are lifted. In many countries, the role of the government in the petroleum sector is being redefined and markets are being deregulated. That is, state interventions such as special treatment of state-owned oil companies, price controls and restrictions to trade and are being removed. As a result, the petroleum sector is becoming more and more competitive. In a market where price is regulated and therefore almost uniform, factors such as convenience and product or service differentiations play a more important role in winning the market share. When price becomes free to move, it assumes great importance in winning customers. As prices begin to vary for the same product, customers differentiate outlets not only by the quality of the offering and the convenience of acquiring it, but also by the price being charged.
Have you ever been pumping gas in your car, then all of a sudden, it just shuts off in your hand? Bam, maybe it takes a finger off, that kind of thing. How does a gas nozzle know when to shut off? Well, I'm here to explain. It's actually surprisingly complicated. Have you ever heard of the Venturi effect? If you take a tube and you pinch it in the middle, then fluid, and remember fluid can be gas, can be liquid, doesn't just have to be water or something. After the pinch, after it goes through the pinch, it becomes compressed, and as its velocity speeds up, the pressure on the other side of the tube actually decreases. Keep that in mind. That's the Venturi effect. If you look at a gas nozzle, you'll see a little hole toward the end, and that hole actually leads to a tube. Now that tube runs all the way up the length of the gas nozzle, and it usually tees off. On one side, you've got a Venturi tube. On the other side, you've got a tube leading to a diaphragm of air. Now that diaphragm of air is all blown up nice and big while there's air running through the nozzle sensor. So while you're pumping gas, and gas is in the tank and you're still filling it up, air is moving through this little sensor pipe quite nicely. The pressure on one end of the Venturi tube, which is on this side, is nice and low, and on the other side, the diaphragm is nice and puffed up. Air pressure, no problem. But as the gas starts to rise, maybe it starts to foam, or it starts to just simply fill up the tank, that sensor, that pipe, starts to suck up gas. And when the gas is sucked up, the density of gas is a lot heavier than the density of just air. The Venturi tube all of a sudden changes in pressure, which creates suction on the other end of this pipe, which sucks the diaphragm, which collapses a little bit, triggering an automatic shutoff. Seriously, that's what's going on in your gas nozzle when you're pumping gas and it fills up. That's how it knows your tank is full.
Petrol retailers in any geography face the following key challenges with underlying objectives: retain or increase market share, optimize profitability at point of sale by reducing operation costs throughout the supply chain, optimize gas station network, manage and reinforce customers' perception for right quality and quantity. Gas station automation system. Gas station automation system provides monitoring, control and management of gas station with following major components. Forecourt controller to monitor and control forecourt activities. Outdoor payment terminals to provide various payment methods, enable dry stock sales on fueling aisles, provide fueling receipt, enable attendant tagging, forecourt shift management, etc. Fleet management system. Fleet management system provides a unique way to handle fleets at gas station. The VIU vehicle information unit fitted in each fleet vehicle is hooked up to the odometer and with fuel cap. Once connected and initialized, the VIU will keep correct log of the miles traveled and also details on the fuel type required for vehicle, registration number, etc. Whenever a fleet vehicle reaches gas station for refueling, the automation system will communicate with the VIU to upload odometer reading, type of fuel permissible, etc. and will grant automated authorization. Fuel delivery management system terminal. Fuel delivery management system manages the demand fulfillment side of the petroleum supply chain. It ensures a secure delivery of petroleum products from terminal to gas station and as per the replenishment schedule worked out by the secondary distribution planning and scheduling system located at the area office. Control room based management, integrating the various elements of data that is being collected from the field on a 24/7 basis can be a very onerous task. Sorting and viewing that data to ensure that all business parameters are being met is now possible in the comfort of a 21st century control room. Supervisors and analysts manage the entire retail operation using a central vivid display system. At the marketing head office level, usually technology enablers like dynamic pricing, secondary distribution, planning and scheduling, and demand forecasting are deployed to enable quick decision related to pricing, forecasting and replenishment across the secondary supply chain. Now moving on to the next topic, we will talk about technology. All technology involves systems. Systems take a variety of inputs and process them in some way, usually by an interaction of subsystems, and then they generate a set of outputs, some of which are desired and some of which are unwanted byproducts. All of this occurs within a context or environment. At various points during the process and at the end of the process, effective systems use feedback and assessment systems to generate information about how well the purpose for which the systems was designed is being achieved. Nature of technology. The nature of technology strand sits within an overarching view that sees technology as a group of socially embedded activities termed technological practice that are driven by human will in response to need, desire, and or opportunity. Key to this practice is its purposeful and productive nature. This means that outcomes are arrived at through an intentional process of design, decision-making, production and manufacturing rather than through processes of the natural world or thing occurring by chance. Needs, desires and the identification of possible opportunities provide the initial impetus for technological practice to be undertaken to develop fit-for-purpose technological outcomes. Technological outcomes include technological products and systems developed to extend human sensory perception and of physical ability. In this way, they serve as a means of extending the natural functioning of the human body.
How do you connect retail in store to what people are doing online? They don't have to be separate.
We had the notion of doing some meal planning. Consumers have more information and have access to more information. Intel had great readily available technology. We had a wealth of information and recipes, and we just brought the two together to solve problems that previously didn't have a unified solution.
The blend is being able to bring online in store. How much nicer would it be for me to walk into a store and walk up and it knows it's me because I've allowed it to either access to my phone or some other way of identifying me personally, and it says, Frank, welcome back, and we've got special discounts just for you.
We're going to help make their shopping experience more seamless, easier, quicker, a little bit more fun.
That interactivity piece makes you want to go to a retail store now.
So innovation is a little scary, and innovation is hard, but I think we've seen over and over again that those who create things that are very different and provide incremental value to people are those who win. They're the ones who triumph in the end.
When things become personal in technology, you're starting to hit a breakthrough. It's when they're not personal that there's a problem.
I look for opportunities now that I perhaps wouldn't even have thought to seek out, prior to stepping into this role and having had this experience. I'd ask any wary retailer, do you want to wait until the future happens to you, or do you want to be involved in helping create what that future is? So jump in and help make it work for you and your outlet and your shopper.
You don't say you're a sponsor of tomorrow. You are a sponsor of tomorrow, and you demonstrate that in what you do.
Let us now know the meaning of technologies and business. Technology plays a key role in today's business environment. Many companies greatly rely on computers and software to provide accurate information to effectively manage their business. It is becoming increasingly necessary for all business to incorporate information technology solutions to operate successfully. One way that many corporations have adopted information technology on a large scale is by installing enterprise resource planning (ERP) systems to accomplish their business transaction and data processing needs. ERP systems. Enterprise resource planning (ERP) systems are software packages that use relational database technology to integrate various units of an organization's information system. ERP systems provide several but integrated modules which can be installed as a package for any organization. Many large corporations use several different and separate information systems, often because they have merged with and or acquired other companies with varied systems. An ERP system integrates these separate information systems and results in improved data reliability and processing efficiency. Corning went from having over 200 legacy systems to fewer than 10. The main obstacle to installing an ERP system is the next cost. It can cost upwards of INR 2,050 crores to implement a large-scale ERP system. However, an ERP system can provide significant benefits by improving information processing quality and thus management decisions related to business operations.
ERP makes businesses more efficient. It makes businesses more profitable, gets employees paid on time, lets management make smarter and more strategic decisions, and even gets your products to your customers. Sounds pretty cool, right? Okay, so now that we know that, what exactly is ERP? ERP is Enterprise Resource Planning. Easy enough. We can all go home happy. Unless, of course, you never got around to taking that course in school entitled Vague Business Terms that got shortened into authoritative acronyms to make them sound more credible. The reality is that ERP is an umbrella term for a very complicated type of software solutions. Sorry if you were looking for a simpler answer. Let's see if we could take a few minutes and introduce you to our new friend ERP and talk about how it could really help your business. So you wake up one morning with an idea for a new product. A good idea, maybe even a great idea. But your idea and a couple of bucks might get you a cup of coffee. What do? How do you make or get that idea turned into a product that customers like so much they want to give you money for it? You often start with making your idea into a design. When you start to design your product, you need to define it exactly, maybe even draw it out. ERP doesn't do that. What ERP does do is to help you start compiling a list of all the materials you'll need if you ever want to eventually build your product. While you go through the design process, ERP will let you estimate what making each unit will cost and how you decide to price it. Hopefully, your price exceeds your cost, and you discover that this idea of yours might actually fly. Now you decide to transfer that design to manufacturing. No matter how pretty your design is, customers won't give you money for it, any more than they would for the bare idea. So now you have to make your two-dimensional idea into a three-dimensional product. ERP helps out here as well. It allows you to set up a supply chain, bringing all the necessary materials together to build your product. Vendors from all over can be accommodated by ERP, which can send them purchase orders for those materials. When the materials are ordered, a schedule for their delivery, shipment instructions, payment for these materials, and eventually their arrival and receipt can all be handled by our new friend ERP. These materials can even be identified in the warehouse using straight logistics, barcodes, or even radio frequency. ERP will handle all that for your business as well. Maybe your original idea was not to make or design your product, but buy it from somewhere else and distribute it into a new market. ERP doesn't mind. It will take care of you all the same, tracking your inventory of raw materials or bought goods for resale without showing any favoritism. While all this making or buying is going on, you've sent out a sales team to find those customers out there who desperately want to give you money in exchange for your brand new product. Their job is to get those orders rolling in. Your ERP will obviously take care of those orders, but can also keep track of the salespeople's territories and their commissions. And then the day arrives. Customers appear over the horizon, eagerly waiting to give your product a new home on their shelves. ERP will welcome those customers in and take all their information for them. It will help you keep track of all their many wants and needs, including the fact that they want your product to be customized just for them. And when they say the check is in the mail, you could trust their credit for 30 days to the extent of $200,000. ERP accepts their orders and will automatically figure out what is needed to fulfill them, how long it will take, and what you should charge for those orders, including all the local sales tax deductions. In the case of really big and demanding customers, they're using something called EDI. An ERP will often include an electronic data interchange module as well. ERP will help you fulfill those orders. If you're in the distribution business, ERP will tell you how much inventory you have on hand, where it is physically sitting, and give your packers instructions on what to pick and put into the containers for those customers. ERP will arrange the shipments to get your product to your customer, fill in the paperwork for you, even the custom stuff to get it over national and international borders. ERP also determines what each of your packers get paid, writes the checks, and makes automatic deposits for them. If you actually manufacture the products you are selling, ERP will translate sales orders into detailed work orders, outlining each step of putting your product together. How much material it will take, the labor involved, quality assurance processes, and even what tools or machines are needed in the manufacturing. It will pay your production staff by the hour, or maybe by the work done, or even a mix of both. ERP knows what your team knows and makes sure that people are assigned to jobs that they are trained for. It will track where the finished goods go and how they eventually get put into containers to fulfill orders and then shipped, just like with distribution. All this information allows it to compile some pretty amazing reports and statistics, so management can make themselves look all-knowing with very little effort. That's part of their job description, right? A live dashboard of what is going on throughout the company is available so decisions can be made on an up-to-date informational basis. Not that running a business by the seat of your pants every day isn't exciting, but our friend ERP is a little vain and avoids getting gray hairs. ERP will also help you put together your financial documents for filling in your taxes and submitting your remittances. So what does ERP do? A lot. And that was only a very basic description.
The downstream business is divided into refining and distribution segments. Since there is a lot of interplay between the two segments, a brief description of the refining business is also included. The refining business segment supply chain is managed by using linear programming packages, which can evaluate crudes, schedule cargoes, and blend streams to give products. In addition, in manufacturing, kinetic models and yield accounting packages optimize the performance of different conversion units. There is a definite shift in focus in the industry toward the distribution segment. The big oil companies have started monitoring the inventories of gas stations and are using the demand data from such outlets to plan for the refinery throughput. The issues at the refinery level are which crude oil to use, which units to run, which products to make, and in what quantities, while the issues at the customer-facing end or at the gas stations are basic, namely run-outs and retains. Run-outs are loss of customers as the station has no gas and can potentially turn away the customer forever also. Retains are slightly manageable as they involve just the demurrage which has to be paid for holding a loaded truck till there is all latch in the station's huge tanks. Demand forecasting. The demand number for each product for the forward month is one of the key inputs which is essential for the refinery LP to perform the optimization studies. This input actually determines the rate at which the refinery operates for the next month. This decision helps in buying crude so that there is no dry out or lack of crude for running the units or demurrage due to a high inventory build-up. The demand numbers are generally taken based on following inputs: historical data for the similar period, forward trades data based on deals done or committed in the forward months, the POS systems which give the latest updates, macroeconomic indicators reflecting the economy, marketing inputs based on marketing plans to introduce new schemes, etc. in a month for attracting customers, Meteorological department's inputs as the gasoline and heating oil requirements are very weather sensitive. Even though all these inputs are considered, an element of subjectivity comes in while giving weightages for each of these factors. The weights can vary with time or with individuals, leading to different predicted numbers. Supply and distribution plans. The logistic management group coordinates the movement of products from the refinery grade to different customers and retail outlets. A ship waiting to be loaded or unloaded costs demurrage. Accrued VLCC alone incurs around INR 15 lakhs per day of waiting, and the customers waiting to get the cargo may also levy penalty clauses for the delays. If there is a delay in product evacuation due to improper scheduling, the product tanks get filled up and leading to a chance of throughput reduction of the refinery itself. In worst cases, there is a chance of crude vessel incurring huge demurrage. On the other hand, the early arrival of product vessels may lead to insufficient stock in the tanks, and there would be dead freighting, which is uneconomical. For products moving through pipelines, pipeline scheduling is important. Pipelines would typically pump batches of around 1000 KT. These batches cannot be normally interrupted. Also, the material which was pumped before and after the product has an impact on the quality of the interface and needs to be considered during pipeline scheduling. In most of their refineries, the objective is just to move the right material from one place to the other at the right time, which in itself is considered a challenge. Such methods are not necessarily the best or optimum methods, but in these times of severe competition, margin is in the range of 8 to 10 cents per barrel. On distribution methods are considered really attractive. The focus has moved from just delivering the right amount of the material at the right time in right quantities to delivering all that at least cost. Replenishing the retail outlets. The fundamental issues for a gas filling station are run out and retains. Even though there is a weekly and monthly plan for distribution for all the gas stations, the scheduling for refilling of the stations needs to be done properly. If there were unlimited tankers topping up these gas stations, there would be no issue. But typically, there would be a single tanker which would cater to a neighborhood having many filling stations, and its optimum utilization means better utilization of the tanker itself as well as prevention of run-outs and reruns. It makes economic sense too, as each fruitless visit of a tanker costs around INR 7,500, and with a mid-sized company having around 4,000 outlets, these costs add up fast. Software tools available. In this process, the scheduler can make necessary changes to the optimized plan if there are modifications to the transport schedule, sudden transport unavailability, sequencing, delays, compartmentizations, modification, etc. Those changes are then sent back to the replenishment planner for schedule confirmation. These new actual trigger is a series of automated supply chain adjustment that can extend up into the refinery and crude selection if warranted. The end result is completely integrated, dynamic and self-adjusting supply chain planning and scheduling. Demand forecasting. A variety of models are used for answering the basic questions of how much product will be needed at each of the terminals for a particular time period. Intelligent neural network algorithms are being used for making such models. The neural network simultaneously evaluates various statistical forecasting methods and weighs them according to their accuracy as compared to historical data to create a composite algorithm. Some of the attributes of these functions specifically desired for bulk refined product demand planning are demand planning by individual product and customer, by channel of trade, the demand plan to be done over different time periods, short, medium, long term, the economic impact and the effect of price and availability of a substitute for products on demand to be considered. The demand forecasting tools using neural network apply the forecasting methods like daily average, day of week average, seasonal, etc., which learns from past experience and projects for the future. These models use other functionalities like linear regression, which find the best straight line through the last 2 years of data and extrapolate this line into the future to predict future sales. Sometimes exponential regression, which attempts to best fit an appropriate exponential function using power regressions where the data is best fit according to a power function is used. The forecasting tools have evolved to such an extent that they allow users to modify or enhance the forecast using other tools for sales anomalies that the system would have no way of predicting. Sometimes a user needs to retrieve from the historical database an event that caused a fluctuation in demand. They can then map the historic sales patterns of those days to a future period of time. This is extremely useful in accounting for sales trends that occur on non-consistent events such as sporting events, non-calendar specific holidays, promotional events, hurricanes, blizzards, and other types of anomalies that affect petroleum consumption. Supply and Distribution Optimizer. This tool is primarily for optimizing the distribution segment. The purpose of this tool is to evaluate the different options of transporting the different products to different terminals based on demand forecasts and forward prices so that the margins are maximized. The economic optimization is accomplished by using the linear programming technique. The margins calculated include sales revenues as well as the cost of purchase, production, inventory holding, transportation, and materials handling. By using its mixed integer programming MIP option, the network optimizer also permits the user to define variables that can only take on integer values. This capability permits the modeling of the use of whole container of vessels and a variety of either or situations. The optimizer input or output may have a number of maps associated with the model. These maps are used to input data as well as view results. The distribution network optimizers plays a key role in not only making the best use of capacities in the system, assets utilization, but also ensures that all forecast demands are met, prioritizes the distribution to make the most economic sense. There are different means of taking the product from one place to another. It can be a pipeline, a container, rail wagons, or road tankers. Replenishment and scheduling. The given two steps clarifies how much quantities are to be moved and from where so as to get the optimum routes which would minimize the cost. The important question to be answered now is when. There are tools available which work with LPs to arrive at schedules. They use heuristic algorithms that analyze all possible combination of delivered volumes and available transport to come up with the lowest cost, highest profit solution. These systems determine delivery windows rather than simply run out points in order to allow added flexibility for the application to minimize cost and eliminate supply chain failures. By determining both the retain no-fit point and the run-out point, the replenishment scheduling tool gives itself added abilities to evaluate all opportunities before generating the optimized replenishment plan. To generate the optimized plan, the replenishment planner utilizes cost minimization and profit maximization heuristic. Tools solve all the problems. It would appear that streamlining the entire downstream distribution is just a matter of implementation and integration of the above tools. Most of the available software claims a saving of 6 to 8% reduction in transportation costs alone by using an integrated package. However, there are issues that are still not resolved as discussed. A major drawback of the demand forecasting tools is that they are inward-looking and seek answers from history. They ignore the biggest spoil sport in any plan, that is the competition and their strategies. These need to be countered strategically while taking out the demand numbers. The demand forecasting tool's accuracy is high only over longer periods, and this does away the advantage they claim to give for being very responsive to demand fluctuations. The integration of these forecasting tools with the refinery LP is a major issue, and many refineries struggle with the online integration of these diverse tools. In most cases, the transfer of data from these tools to LP is manual, and hence the optimization across different sets of forecast data is lost. In the supply and distribution optimization, wherein the prices of different products are taken differently for different areas for reflecting the cost of transportation inputs on correct prices become the key parameter for optimization. Thus, the focus is on estimation of correct prices that can alter the optimization process dramatically. Inputs from POS systems are good and help in managing the stocks in ROs by moving material from the nearest storage terminal. But there is disconnecting here between whether the movement is as suggested by the forecast and plan or an unexpected demand. There is a gnawing doubt about whether this was the optimum solution. Now, in the end, let us summarize what we have learned in this lecture. Fuel Delivery Management System manages the demand fulfillment side of the petroleum supply chain. Enterprise Resource Planning ERP systems are software packages that use relational database technology to integrate various units of an organization's information system. The refining business segment supply chain is managed by using linear programming packages which can evaluate crudes, schedule cargoes, and blend streams to give products. The role of technology in petroleum retailing needs to be explored in a way that encompasses the interests of multiple stakeholders, namely supplier, retailer, and consumer. The important functions within the distribution segment are demand forecasting, optimizations across alternative means of transportation, replenishment methods to avoid retains or run-outs, and finally scheduling, which sequences the dispatch.